Okay, class, so this is part 2 of section 7.2. We're going to discuss the second technique. In the previous technique, we went ahead and discussed what was known as the slope-intercept form. This is known as the standard form. And in this case, you're going to see right away that this technique works best if you have problems like this, where you have your x and y on the same side. Yes, you could still do it with the other type of equations that we had. We could do it with these that are set up equal to y, but it works best with these types of equations where you have x and y first. So just remember this. T-tables, use it when you're dealing with equations that are set up equal to y. The standard form, or what is known as the X Y Intercept form, is better for problems that you have x and y together right there. So once again, this is known as the X and Y intercept form, and preferably it's for those equations that are in standard form. So how does this work? Well, first thing that you have to do is you're going to have to go ahead and take a look. What is your x-intercept? What is your y-intercept? Alright, so those are very simple. For the x-intercept, what you're going to do is you're going to let y equal 0. Once again, you're solving for x here. So you substitute the 0 in there. So this will be x minus 0 is equal to 5. And x minus 0 is just simply what? X. So your x is equal to 5. So your x-intercept is 5, 0. Now the only thing that's going to happen here is that these are going to be on your axes. Either it'll be on the x-axis or the y-axis, depending on what you're solving for. Alright, so that's your x-intercept. The second one is your y-intercept. So the y-intercept, all you have to do here is substitute the opposite. You let x equal 0. So here we're solving for y. So we're substituting the 0 in there for x. So this will be 0 minus y equals to 5. Once again, what you're going to have to do here is go ahead and calculate this. 0 minus y is just simply negative y. But remember, we cannot leave a variable with a negative. So this is like saying that you have negative 1 in front of there. And we simplify it. So we divide this by negative 1, divide by negative 1, so y equals negative 5. So that is your y-intercept, 0, negative 5. Now they're going to ask you for a third point. If you want to solve for the third point, you would have to go back to the t-table method that I showed you in a previous video. But technically, you only need 2 ordered pairs. You only need 2 points to make a graph. So I'm only going to show it to you with the 2 ordered pairs. If you want to go with a third point ordered pair, that's fine, but you don't necessarily have to have it. So in this case, you have 5, 0, so it's not going to move. It's going to move on the x 1, 2, 3, 4, 5. But you're going to notice something a little bit different. It's not going to go up or down. It's going to stay right there. That's why it's called the x-intercept, because it's a point that is on the axis. It's not going to be on these regions, on these quadrants right there. So it'll be right there. So this will be 5, 0. Your y-intercept will be 0, negative 5. So remember, it's not going to travel on your x, but it's going to move down 5. So it's going to go once, twice, 3, 4, 5. So 0, negative 5 is your y-intercept. Now remember, why is it called your y-intercept? Because it's on the y-axis. Alright, so remember, x-intercept is on the x-axis. Y-intercept is on the y-axis. And once again, just like our previous section, if you connect these two, they should form a straight line. If they make some type of curve or something very drastic, that means that more than likely your calculation went bad. So it does form a line. And that is your graph for that one. Once again, you do not have to spend a whole lot of time with these things. You just got to know which technique are you using. Are you using the t-table method or are you using the X Y intercept method? And it all depends on how your equation looks like. So the next problem is very similar to this one. So now that we know how to do the X and the Y intercept, we're going to practice some more with this. So remember, the first step is to go ahead and figure out the X intercept. And according to our previous example here, our X intercept, we're going to let Y equal 0. So once again, substitute the 0 in there for Y so we could solve for X. Remember, X intercept, we're looking for X. So it'll be 2x minus 3 times 0 equals negative 12. Now, it may look a little bit complicated right here, but remember, negative 3 times 0 is just simply 0. So it's 2x minus 0 equals negative 12. And 2x minus 0 is just going to be 2x equals negative 12. Then we just simply divide to solve for x. So we divide both sides by 2. So x equals negative 6. And that is your x-intercept. Your x-intercept is at negative 6 and 0. We're going to do now the same thing, but now for the y-intercept. So remember, the y-intercept, we're going to go ahead and let x equals 0. And we're solving for y. We're looking for y here. So substitute the 0 in there. So this will be 2 times 0 minus 3y is equal to negative 12. Well, just like we had before, 2 times 0 is just going to be 0. Bring down the minus 3y. Bring down the negative 12. And 0 minus 3y is negative 3y equals to negative 12. And we're going to divide both sides by negative 3. So y equals positive 4. So your y-intercept is at 0, 4. So there you have it. You have your two ordered pairs. Just plot them and connect them, and it should form a straight line. So the first one is negative 6 and 0. So it's 1, 2, 3, 4, 5, 6. So it's right there. And the other one is 0, 4. It's not going to move on the x, but it's going to move up 4. 1, 2, 3, 4. So it's going to be right there. All right, so let's go ahead and connect these two. So once again, you do not need any fancy calculator to do these graphs. You guys could do this. It's just a matter of concentrating and choosing which technique you're going to choose. Are you going to choose the t-table, or are you going to use the XY intercept? All right, in a minute we'll take a look at part 3.